Today, we are diving deep into communication protocols for AI agents. We will learn about the main protocols that are shaping how AI agents interact with the external world and with each other. AI agents are becoming more capable with new ways to communicate, access tools, and process information. In this video, we will compare three brand new protocols: Model Context Protocol from Anthropic, Agent to Agent from Google, and Agent Communication Protocol from IBM. If you are a developer, a solutions architect, or a business leader, you need to have a clear picture of the purpose and characteristics of these protocols to build the most scalable, flexible, effective, and extensible solutions. By the end of this video, you will understand what each protocol does, how they differ, and how they might work together to create a powerful and interoperable AI agent systems. Agent protocols are aiming to make the world of AI agents less fragmented. Developers are building AI agents using dozens of different frameworks like LangChain, Crew AI, AutoGen, and many others. Each framework has its own way of defining how agents access tools, store memory, and communicate with other agents. When we look at the AI agent ecosystem, we can identify a couple of areas that can benefit from standardization. First, how agents access tools and data. This is the interface between an AI agent and the external systems, including databases, APIs, and local resources. The second is how agents communicate with each other. This is the protocol that allows multiple agents to collaborate, share information, and coordinate their actions. And the third one is how agents handle natural language processing. This addresses the unique challenges of working with language models that process unclear human instructions. The three protocols that we're discussing today, MCP, A2A, and ACP, each focus on slightly different aspects of these challenges. We will go deeper into each one in detail, starting with Anthropic Model Context Protocol. Let's take a closer look at the Model Context Protocol, or MCP, that was developed by Anthropic. MCP has been gaining significant traction in the AI community since it was released. MCP is designed to standardize how applications provide context to LLMs. The fundamental problem that MCP addresses is how we efficiently and securely provide LLMs with the context they need to perform useful tasks. Before MCP, developers were implementing these connections in ad hoc ways, which can lead to inconsistency, security concerns, and duplicated effort. MCP architecture consists of the MCP host, MCP clients, and MCP servers. MCP host is the program that uses an LLM at its core and wants to access external data. MCP clients maintain connections with servers. MCP servers are programs that expose capabilities through the protocol, and they can access local and remote data sources like computer files, databases, services, and other external systems. MCP provides clear separation of responsibilities. Prompts are user-controlled. These can be injected into applications and are specifically designed for interaction with data exposed by the server. Resources are application-controlled. These can be any kind of data, whether it's text or binary, that applications built on LLMs can use. The application programmer can decide how this information should be used. And tools are model-controlled. These provide agency to applications for interacting with the environment. The MCP server exposes an endpoint listing all available tools with their descriptions and required arguments, which allows LLM to decide which tools to use for specific task. Practically, MCP allows agents to talk to real-world tools and applications to get things done. It connects AI applications to various services like GitHub, Slack, Gmail, databases, APIs, and local file systems. The focus is on standardization without reinventing the wheel. It doesn't try to replace existing tools or frameworks, and instead it provides a standard way for them to connect to LLMs and makes the entire ecosystem more efficient and interoperable. Now let's dive into Google's agent-to-agent protocol, or A2A. So MCP focuses on how agents interact with tools and data sources. Agent-to-agent protocol solves a different challenge. How do agents communicate with each other? This is useful for systems where multiple specialized agents collaborate to solve complex problems. Agent-to-agent is an open protocol that provides a standard way for agents to collaborate with each other regardless of the underlying framework or vendor. Google explicitly states that agent-to-agent is complementary to MCP and not competitive with it. The protocol facilitates communication between what it calls a client agent and a remote agent. The client agent is responsible for formulating and communicating tasks, while the remote agent is responsible for acting on those tasks to provide information or take action. A2A is built around 5 key design principles. First, it has agentic capabilities. This means A2A focuses on enabling agents to collaborate in their natural, unstructured modalities, even when they don't share memory, tools, or context. It supports true multi-agent scenarios without limiting an agent to being just a tool. Second, it builds on existing standards. A2A is constructed on top of popular standards like HTTP, SSE, JSON RPC, which makes it really easy to integrate with existing IT stacks, and businesses already use them daily, so it's really easy. Third, it's secure by default. A2A is designed to support enterprise-grade authentication and authorization. It supports long-running tasks. A2A is flexible enough to handle everything from quick tasks to deep research that might take hours or days when humans are in the loop, which provides real-time feedback and state updates throughout the process. Agent-to-agent is agnostic of the type of content format. So A2A isn't limited to just text. It supports various modalities like audio and video streaming. There is a couple of powerful capabilities that agent-to-agent provides. Capability discovery. Agents can advertise their capabilities through an agent card in JSON format. This allows client agents to identify the best agent with a particular task and leverage A2A to communicate with that remote agent. Task management. Communication is oriented toward a task completion. Tasks have a defined life cycle and can be completed immediately or tracked for long-running processes. The output of a task is called an artifact. Agents can send each other messages to communicate context, replies, artifacts, or user instructions. Messages include parts, which is fully formed pieces of content, with specified content types, which allows agents to negotiate formats and UI capabilities. Google showed A2A with some real-world examples like candidate sourcing, where multiple specialized agents collaborate across a hiring workflow. The production-ready version of A2A is expected later in 2025, but the protocol specification is already available to explore. So A2A is focused on agent-to-agent communication, rather than agent-to-tool communication, and this addresses a different part of the AI agent ecosystem than MCP, which is why Google suggests using both protocols together, MCP for tools and A2A for agents. The third protocol that we're diving into today is Agent Communication Protocol, or ACP, developed by IBM team. ACP is the newest one in this space compared to MCP and A2A, and it is designed to standardize how agents communicate with a particular emphasis on enabling automation, agent-to-agent collaboration, UI integration, and developer tooling. What makes ACP's approach different is its philosophy on standardization. Rather than imposing strict specifications immediately, ACP takes an evolutionary approach. It emphasizes practical, useful features first, with standardization occurring only once features have demonstrated their value. This makes sure that there is broader adoption and long-term compatibility, and it focuses on what works. The motivation behind ACP is similar to that of the other protocols we've discussed. There are two specific enhancements for agent-based systems that makes ACP different. Natural language flexibility. ACP is designed explicitly for agents handling fuzzy or unclear natural language inputs. This allows more complex and intuitive interactions, and this focus on challenges specific to language models sets it apart from more general communication protocols. Model dependency management is something else that ACP does differently. ACP simplifies the integration and management of externally hosted models. It improves resource management for AI systems that rely on these models. We have examined each protocol individually. Now we will compare them side by side to understand how they relate to each other and where they fit in the AI agent ecosystem. First comparison criteria are their core purposes. MCP focuses on standardizing how applications provide context to LLMs, essentially connecting AI models to tools and data sources. A2A is about standardizing agent-to-agent communication for collaboration between different agents. ACP also focuses on agent communication, but with a particular emphasis on natural language processing and model dependency management. When we compare their architectural approaches, we see that MCP has a clear separation between user-controlled prompts, application-controlled resources, and model-controlled tools. A2A is built around task-oriented communication between client and remote agents, with capabilities like agent cards for discovery. And ACP takes a more evolutionary approach, focusing first on practical features for natural language processing before solidifying standards. The ecosystem and adoption of these protocols are also different. MCP has been gaining traction in the AI agent ecosystem with integration examples across various tools and applications. A2A was just recently announced with the production version that will come later in the year, and ACP is in the early stage of development with less data about its adoption. One of the biggest issues with MCP adoption is related to security and authentication, especially for implementations that securely expose MCP servers remotely. Another gap in MCP is that it doesn't provide options for communication between agents through tools, including exchanging their state and support for long-running tasks. This is something that A2A has an opportunity to take care of. At the same time, maybe Anthropic is actively working on extending the scope of MCP's purpose. Another interesting aspect to consider is where these protocols might overlap or compete in the future. While they currently address different aspects of the AI agent ecosystem, there could be areas where their functionalities can converge. For example, both A2A and ACP focus on agent communication through different emphases. As these protocols evolve, we may see differentiation or perhaps some more consolidation. The key takeaway from this comparison is that these protocols are very new. They're currently solving different parts of the same puzzle. Right now, they are positioned as complementary standards that work together and can create a more interoperable AI agent ecosystem. In the long term, though, I can envision them getting into the competing territory. With MCP's wide adoption, extending it to cover agent-to-agent communication may be in the plan. With Google's agent-to-agent protocol and an already good base for secure and enterprise-ready agent communication, it may quickly take over the space. So what do these protocols mean for developers, businesses, and the future of AI agent development? Theoretically, a standardized protocol has benefits. Rather than reinventing communication mechanisms for every project, developers can use them to focus on building unique agent capabilities, which means faster development, more reliable systems, and easier integration with other tools. However, there is also a risk of fragmentation if multiple competing standards emerge without clear interoperability. The fact that major players like Google explicitly position their protocol as complementary to others is a positive sign, but we will see if industry maintains this collaborative approach as these protocols continue to evolve. My verdict is that it's too early to make a definitive call. We need to give these protocols some time and watch the direction it's going to go, the complementary approach or the one clear leader covering the entire scope. Now you know about MCP, A2A, and ACP and different approaches they take to solve the communication challenges between AI agents and tools. For developers and businesses looking to implement AI agent systems, my recommendation is to use MCP when you need to connect your agents to tools, data sources, and external systems. Implement A2A when you're building multi-agent systems that need to collaborate across different frameworks or vendors. And keep an eye on ACP's development, especially if natural language processing and model dependency management are key to your use case. As these protocols continue to evolve, we can expect to see more interoperability, more sophisticated agent capabilities, and more powerful AI systems that can solve complex problems. Make sure to subscribe to my channel and like this video. Thanks for watching, and I will see you in the next video.
Your reality has changed. You're stuck in your career. You're either using AI or being used. Do you still believe success is guaranteed? You feel it's time to wake up. Old strategies don't work anymore. Welcome to the real world. It will never be the same again. You need to fight for your future. Learn to spot truth from lies. I will help you. Together, we will win.